Very often you are asked to find two unknowns by solving two equations at the same time. And these types of equations are called simultaneous equation. Simultaneous equations are two equations with two unknowns. Simultaneous means both the equations are solved at the same time. There are three methods to solve simultaneous equations. The graphical method, the elimination method, and the substitution method. The first method I'm going to show you is the graphical method. In graphical method, first draw the lines of the equations and then find the point of intersection, which is the solution. For example, solve these simultaneous equations here. First equation, x plus 3y equals 9. Second equation, 2x minus 3y equals 18. Now, to draw the lines on the graph, the easiest way is to pick two easy numbers to plot. For example, in equation 1, when x equals 0, 3y equals 9, so y equals 3. So we have one point on the line, which is 0, 3. And now find another point. When y equals 0, x equals 9. So the another point on the line is 9, 0. So using this method, we can draw the lines on the graph. And we can see here, x plus 3y equals 9, which is the blue line. And 2x minus 3y equals 18, which is the red line. And the point of intersection here, 9, 0. And this is the solution. So the answers for the simultaneous equations are x equals 9 and y equals 0. Simple, isn't it? Using graphical method could be slow though, and a quicker way to solve simultaneous equations is to use algebra. And one of the methods is the elimination method. In elimination method, we try to eliminate one of the unknowns. Here is a very simple example. The simultaneous equations here, 3x plus y equals 9, 6x minus y equals 18. We can add the two equations together to eliminate the y's. And after adding the two equations together, we've got 9x equals 27, so x equals 3. And now we can put x equals 3 back into one of the equations, say back into the first equation. And we have 9 plus y equals 9, so y equals 0. And that's the answer. The answers are x equals 3 and y equals 0. But sometimes we need to multiply one of the equations before we can add or subtract. Now in this example, the simultaneous equations, 5x plus 2y equals 4, 3x plus y equals 3, and we multiply the second equation by 2, making it 6x plus 2y equals 6, which becomes the third equation. And then we can subtract the first equation from the third equation to eliminate the y's. And we come up with x equals 2. And now we can put back the x equals 2 into the first equation. And we have y equals minus 3. And so the answers are x equals to 2 and y equals to minus 3. But in some cases, you need to multiply both equations to find the unknowns. For example, the simultaneous equations here, 3x minus 4y equals 7, 5x plus 3y equals 2. First, we multiply the first equation by 3, making it 9x minus 12y equals 21, which becomes the third equation. And then we multiply the second equation by 4. Now we have 20x plus 12y equals 8, which is the fourth equation. And now we can add the third and fourth equations to eliminate the y's. And now we have x equals to 1. And then we substitute x equals to 1 back into the second equation. And it comes up with y equals to minus 1. And so the answers are x equals to 1 and y equals to minus 1. So in elimination methods, we always look for a way to cancel out one of the unknown terms. Once one of the unknown terms are canceled out, and we can find the solutions for the other one. And now I'm going to show you the substitution method. In this example, the simultaneous equations, x minus 3y equals 6, 3x minus 2y equals 39. First of all, we rearrange the first equations to get x equals to 6 plus 3y. And now we can replace the x in the second equation by substituting it with 6 plus 3y. And as you can see here, we substitute the whole thing into the second equation, and we can work out the value for y, which is equals to 3. And then we can substitute y equals to 3 back into the first equation, and we have x equals to 15. And so the answers are x equals to 15 and y equals to 3.